I'm a teacher Olimboka Sijuga Masame. Welcome to Olimboka Physics. We will use the questions from TAI exercise 4.4 question 2 to understanding the concept of projection lantern and how it's operating. We have a slides projector. Has a projection lens of focal length 15 cm. The projector is to be focused to project an image of slide measuring 5 cm times 5 cm onto a screen measuring 1 meter times 1 meter. How far from the projection lens should the screen be placed? Let us consider the diagrams that shows important parts of projection lantern. And we have these diagrams, as you can see here below. We have a reflector, condensing lens, projection lens or objective lens, and the screen. And this is the slides is placed between the condensing lens and the objective lens. This is the distance for this slides to the projection lens, and which is a object distance by that arrangement. Therefore, this slide is object. Now, the distance from the projection lens to the screen is image distance. Now, the light source is placed at the focal point of the concave mirror or reflector, and also the focal point of this plano. These two lenses are called a plano convex lens. Therefore, they are a couple of plano convex lens. Their focal lengths coincide with light source, and also their focal lengths, other side of focal lengths coincide with a projection lens. Here, as you can see, F for plano, and here is also F for plano. And this condensing lens is placed immediately near to this light source, which is about 2 FM focal length of reflector, the concave mirror. This is it's not a focal length; it's twice focal length of reflector, which is equal to center of curvature of reflector. This FP, this is the focal length for projection lens. As this 2 FP, this is center of curvature of this projection lens. Therefore, the slide must be placed between a focal length of projection lens and center of curvature of projection lens, so that we will get enough large image which is real, and as you can see, there is upright. We know that the slide, so that to produce the upright image at the screen by this projection lens, the slide must be upside down and must be a left-right reversal, so that the final image will be upright and in a normal orientations. Okay. Let us consider this rays. This rays that incidence at a reflector is concentrated to the condensing lens, and crossing through the light source here. Because these rays are crossing through the light source together with these crossing rays will lead to the rises of heat. Therefore, the fan must be placed immediately below this light source, so that to cool it, to avoid it from getting too much hot. Okay. Therefore, this is reflecting rays and incident ray, direct incident ray from the light source will condensed or concentrated by this couple of plano convex lens to the projection lens. This is condensing a lot of rays from the reflector, so that the slide will get enough light so in order to produce a bright image on the screen. If the condenser will condense least light on this edge of the slide will appear blurred on the screen. Therefore, we must have the strong light source and enough, and the ability of condensing lens must be good in such a way that the final image from the screen will be brighter. The distance from the screens to the projection lens must be altered in such a way that the final image will suit the purpose or the audience who take views on it. Okay, let us here are some explanations that have been explained. And a condenser, for the purpose of condenser, must consist of a couple of plano convex lens which are refracting the light rays, and the projection lens responsible to form the final image on the screen, and the slides must be placed upside down so that the final image must be upright, as you can see, and it must be placed between a focus point of the projection and center of curvature. Also, in order to the slide to fit the size of the screens, yes, you must adjust this image distance. And this diagram below is what's indicating the whole components closed to the outer case, the device by itself. This is the place where fans it is. This is the reflector, and this is condenser. This is the bulb. This is the slide. This is focusing knob. Focusing knob is just changing the distance of this projection lens to the mirror by taking it in and taking it out. That's why it is called focus knob here. And this is where we put the slides. Therefore, this is how the projection lantern operates. Okay, from our questions, I've given focal length that is positive 15 centimeters for projections length. We have given the height of the slides, which is 5 centimeter in its height and in its width, and the height of image must fit the size of the screen. The size of screen, which is 1 meter to height and 1 meter to width, which is equal to 100 centimeter. Now, what is supposed to find is our image distance, which must be the one from the projections lens to the screens. The one from projection lens to the screens. Okay. Let us consider the formula for magnifications, which is linear magnifications, which is 80 for image height to object, which is equal to image distance object distance, which is equal to v divided by f minus 1. Therefore, we take absolute of linear magnification so that the magnification here will be positive. In order to get the v, therefore we'll take this to the left, and it will be positive, and 21 times the cross multiplications. V is equal to 21 times 15 centimeter. Therefore, the final image distance is equal to 315 centimeter. Thanks for watching. Please like, share, comment. Don't forget to subscribe this channel for more videos like this one. Thank you.